welcome back to part 2 of inverse operations. We are going to end it out with solving log and exponential equations. Now that we know how these inverse operations work together, we're going to follow similar steps depending on what type of equation you have. So whether it's exponential or log, the first thing you're going to do is isolate your term. So whether it's an exponential expression or a log expression, you will use other inverse operations to undo addition, subtraction, multiplication, or division happening outside of it. Then, depending on whatever form it is, you will rewrite it. So if it's an exponential, you'll rewrite it as a log. If it's a logarithm, you'll rewrite it as an exponential. And then you'll solve only in the calculator if you need to. So we are going to go through 6 examples of this. Starting with A, my exponential base is by itself, so I can go straight to writing this in log form. And that will be log, when my base is 10, I can just say log of 74 is equal to x. Now, this is not a perfect number, so I will utilize my calculator. And we're going to have to round to 3 decimals here. And so x is approximately 1.869. Moving on to B, this is my exponential expression, 4 to the 5x. So I need to move the 8, and I will get rid of it by subtracting because that's the inverse of adding. So 4 to the 5x is equal to 78. Now my exponential expression is by itself, so I can write it in log form, and that will be that log base 4 of 78 is equal to 5x. Now this is not going to be a perfect number, so I'm going to use my calculator to figure out what that is, and that value will be equivalent to 5x. So I'm going to have one more step here after I figure out log base 4. I don't know what I'm going on with here. There we go. Log base 4 of 78 is about 3.143, and if that's equal to 5x, the last thing I'm going to have to do is divide by 5, since that is the inverse of multiplication. And so we get that x is going to be approximately 0.629. Moving on to C, 15 to the 6x plus 1 is my exponential expression, so I've got a couple things to take care of here. Firstly being adding 3, since that's the inverse of subtracting. And then I need to divide by -7, since that's the inverse of multiplying. And so this is going to become 15 to the 6x plus 1 power is equal to 54 and 7 don't divide evenly, so I'm going to leave it as a fraction, but the negative divided by a negative does make it positive. So now that my log is my exponential is by itself, I'll rewrite it as a log. This will be log base 15 of 54 over 7 is equal to 6x plus 1. So this part I will evaluate in the calculator, and I'm just going to separate my work just to make it more clear what's going on here. Log base 15 of 54 over 7, and that's going to be equivalent to 6x plus 1. So I have some additional steps left here. I still have to subtract 1. And then I'm going to have to divide by 6. So here is my final answer to 3 decimal places, -0.041. Okay, that ends off our exponential equations. We are going to move on to log now. So the steps are the same, except that once we have isolated our log, we'll rewrite it in exponential form. So starting on D, my log is already by itself, so I can go straight to putting this in exponential form. And that will be that 3 to the 4th power is equal to x. Well, 3 to the 4th power is 81, so there, we're done. On E, my log expression is here, so that means I need to get rid of the -8, and I will do that by dividing, since that's the inverse operation of multiplying. So log base 2 of -10x will be equal to -1. Now my log is by itself, so I can rewrite it as an exponential. 2 to the -1 is equal to -10x. Well, 2 to the -1 is 1/2, or 0.5. So the last thing I need to do now is divide both sides by 10, and x is going to be equivalent to -0.05, or -1 over 20 if you left it in fraction form. Okay, last but not least, to get my log alone, first I'm going to have to add this 4. Then I can divide both sides by 9. Okay, my log is by itself, so I can rewrite this in exponential form. This will be 5 to the negative 2 equals 9x plus 3. Well, 5 to the negative 2 is 1 over 25, or 0.04. So to solve this for x, I'm going to subtract 3 on both sides. And then I'm going to have to divide by 9. And I'll grab my calculator to help me with that. It's not going to divide evenly. And to 3 decimal places, we've got negative 0.329. All right, that wraps up our notes today on inverse operations.